Hi all, we are from Group 17. This is our open-ended laboratory, which is G43 point load test. Point load test is to obtain the point load strength index IS50 and uncombined compressive strength. This test does not require costly specimen preparation and is quickly, simple test. The failure load P and the distance between the platters These are measured to obtain the uncorrected point load strength P meter squared. A correction is applied to account for the specimen size and shape, and depending on the specimen geometry, three types of tests can be performed, which are diameter, axial, and irregular lump. The objective of the point load test is to determine the compressive strength of all specimens from irregular lump tests. The theory is to predict initial compressive strength of rocks and establish tests from the general purpose rock strength classifications. Besides, the IS50 should be used during classification, and unusual compressive strength is 20 to 25 times point load test, and the IS50 is approximately 0.8 times the initial tensile.
First, we mark a central line at the rock specimen as our reference line for placing the specimen in point load tester. Measure the upper width and lower width of the rock specimen by using the vernier caliper and record it as W1 and W2. Then we need to calculate the average width of the rock specimen. Next, we place the center of the specimen in the point load tester and close the platen until the platen holds the specimen. After that, we measure the distance D between the platen contact points. Last, we slowly increase the load until the failure of the specimen occurs. I record it as the failure log P and repeat the experiment with different rock specimen.
This is a data that we obtained from the point load test. Okay, for this test, we need to calculate all these values by using this formula. First, we need to calculate the cross-section area, which is equal to width average times width diameter. Then, we can find equivalent core diameter, which is equal to 4 times cross-section area that we obtained earlier over pi. After that, we can find the size correction, which is equal to equivalent core diameter over 50 and power it with 0.45. Next, we can obtain the uncorrected point load strength by using the formula load over the equivalent core diameter. And finally, for the load strength, which is IS50, we calculate it using the formula size correction factor multiplied with the uncorrected point load strength. So we need to calculate for each test by using this formula.
From the experiment, we can conclude that rock sample 1 has the highest load strength, which is 5.730 megapascal, followed by rock sample 2 with 3.834 megapascal, and rock sample 3 with 3.135 megapascal. Rock sample 1 has the smallest surface area with 892 mm squared and the highest load 4.796 megapascal.
For point load test, the discussion from the result obtained, rock sample 1 is 5.73 MPa, we get rock sample 2 is 3.834 MPa, and for rock sample 3 is 3.135 MPa. Therefore, we realize that sample 1 has the highest load strength and followed by rock sample 2 and 3. Rock sample 1 has the smallest surface area, which is 891 mm squared, and the highest load, which is 4.796 MPa. For conclusion, we can determine the compressive strength of rock specimen by using irregular lump test. We can conclude that sample 1 is the strongest rock while sample 3 is the weakest rock by looking the load strength value.